Hi everybody, my name is Reese and this is my video series where I show you how to do cool things in SPSS in under 10 minutes. In this video we will explore how to perform a one-way between subjects analysis of variance in SPSS. If you want to work along with me, please feel free to access the dataset from the description below this video. Quick disclaimer, this video does not explore the appropriate assumption tests for this analysis. I have assumed that all assumptions have been met. If you are performing your own analyses, please make sure you test for the relevant parametric assumptions. Before we jump headfirst into SPSS, let's just briefly revise the purpose of analysis of variance. So conceptually, ANOVA is very similar to t-tests in that they aim to compare means. In the context of a one-way between subjects ANOVA, we aim to compare 3 or more independent group means, so you can think of this as a more complex version of an independent samples t-test. In ANOVA, the F ratio is our test statistic, which gives us an indication of whether there are significant mean differences somewhere between our group means. As ANOVA has 3 or more means though, a significant F ratio doesn't necessarily tell us where those mean differences are. So whilst we get a bit of an indication of what's going on in our data, we don't know the specific nature of the group mean differences. So following an ANOVA, we usually perform what are called follow-up tests. So there are 2 general streams of thought here. You can either do planned contrasts, where you explore very specific planned a priori hypotheses, or you can do more an exploratory focused approach. This is called post hoc testing. As I'm sourcing data online, I don't specifically have a train of thought to follow here. So I'll show you where to perform particular follow-up tests, in that I'll show you where to go to perform planned contrasts, or I'll show you where to go to perform post hoc tests. However, I won't specifically take you down one train of thought. Okay guys, now we've got a bit of that theory out of the way, let's jump into SPSS and start playing with one-way ANOVA, shall we? So I have a data set open here and it's pertaining to IQ scores. Now, I do have the dataset link in the description below this video if you would like to follow on. But the actual IV and DV in this dataset is we have an IV here called group. And let's go ahead and look at the levels. So we've got 3 different levels here. We've got either chemistry students, math students, and physics students. And we're looking at how IQ scores differ between these different types of undergraduate students. So if I move to the variable view very quickly, I'll show you that group here. We've got physics students coded as 1, math students as 2, and chemistry students as 3. That is a nominal variable. And I have IQ score here set as scale. Now going back to the data view, you'll see that the IQ scores are not on the typical scale of IQ. So the IQ scale that I'm particularly used to is one where the mean is 100 and the standard deviation is 15. So these IQ scores seem to be on a much smaller range. So don't let that throw you at all. It's just a different IQ test which has been used on these particular participants. Now, to perform a one-way ANOVA, we go up to Analyze, Compare Means, and then one-way ANOVA. So we'll find that little function tucked away there, and I'll just drag this function box back into view. So in the one-way ANOVA dialog box here, we have a place for our dependent variable and a place here for our independent variable. So I'm going to go ahead now and place group to be my factor and IQ score to be my dependent variable. Now as you can see here, we've got some options on the side. If you had planned contrast, so as I was discussing before, if you had some sort of set of a priori hypotheses that you wanted to perform after your F ratio, you could select contrasts here, and you could actually set up some contrast weights so you could test specific group differences. So for example, if you wanted to see whether maths and physics students together differed significantly from chemistry students, you could look at that specific hypothesis if you wanted to. Now, this isn't my personal data set. I don't know anything about the theory behind this data set, so I'm not going to be playing around with contrast today. Similarly, if you had a more exploratory approach, so if you wanted to look at mean differences after your F ratio was conducted and it was more post hoc line of thinking, you could select post hoc here, and you've got different options about which post hoc test you would like to perform. Again, we're not going to be selecting them in this particular video. Under options, you can select some cool stuff here, and I'll go ahead and select a couple of these. So I'll look at my descriptive statistics. So that's just going to give me the basic means and standard deviations of all my groups. If I wanted to, if I was looking at the assumptions of one-way ANOVA, I could select homogeneity of variance test as well. We won't be exploring any assumptions today, but if you wanted to, you could select that. And I might go ahead and select a means plot as well. There are a couple of other options here, which are slight variations on one-way ANOVA, but we're going to keep things nice and simple in this video and just stick with the generic stock standard one-way ANOVA. So I'm going to go ahead now and select continue, and then select OK to produce our one-way ANOVA output. Okay, so let's start looking at this one-way ANOVA output in a little bit more depth. So the first table are my descriptive statistics. So it gives me things like the sample size, the mean, the standard deviation, confidence intervals around those means, those sorts of things. So just looking at the descriptive statistics here, it looks like physics and math students have the lower IQs of the three groups here, with chemistry students having the largest mean IQ score. Whilst we get a bit of an idea of what's going on in our group means from the descriptives table, to assess whether there is a significant mean difference here in our sample, we need to look at the ANOVA table here. And the key statistic that we use for interpretive purposes is this p-value here. Now it looks like it's 0.000, but there would in fact be a number there. It just happens to be very small. Now the way in which we interpret this figure here, if this p-value, if this significance level is less than 0.05, we can confidently state that there is a significant mean difference across our particular groups here. Or more specifically, that IQ scores vary as a function of type of student. So something is going on here. If we look at this F ratio, we can see that it's equal to 20.016. This F ratio is our test statistic. Now, I'm not going to go too much into depth about what this F ratio means, but I will let you know that the larger this F ratio, the smaller this p-value becomes. So you can kind of assume, or you can kind of interpret this F ratio as being the larger this number happens to be, the larger the effect is of student type here on IQ scores. If you want to go in a little bit more in depth, you can calculate something called an effect size. Now, an effect size gives us an indication of the size of the relationship, and in a one-way ANOVA, the effect size is called eta squared. SPSS doesn't actually give us the value of eta squared, but it does give us an easy way to calculate it ourselves. So, eta squared happens to be the sums of squares between the groups divided by the total sums of squares. Now, the larger that number is, the larger the effect the IV is having on the DV. So you can see here that the sums of squares is equal to about 1500, the total's about 3000. We'd end up with an R squared figure roughly of about 0.5-ish. Now that's quite a large effect size. So it looks like the type of student is having not only a significant effect upon IQ scores, but quite a large effect as well. If we scroll down a little bit further, we can see this in a graph as well. So we can see the two groups which don't differ too much. They're physics students and math students. However, there is quite a large difference here for the chemistry students in our particular sample. Bear in mind my point before regarding the F ratio only telling us there's a significant difference somewhere. We haven't actually tested the specific mean differences between these groups here. If you wanted to perform that, if that was a part of your hypothesis, you would have to go back into Analyze, Compare Means, One-Way ANOVA, and you'd be looking at performing either an a priori contrast or a post hoc test here. and that would give you more of an indication of what is going on between these individual group means. That wraps up this short video today on between subjects analysis of variance. Hopefully now you can confidently perform a between subjects ANOVA in SPSS and can interpret the relevant output. I hope to catch you for another one of my stats videos where I continue to explore more cool things in SPSS in under 10 minutes.